Okay, so the previous video we talked about the features of a compass, and we kind of started getting into a little bit how to use your compass with your map. Okay, so we got the kind of general use of the compass. Let's talk about how a compass is used with a map. So the first thing that we're going to do with our compass is, remember, there's two functions that the compass provides, which is it helps create orientation and it helps create position. And so if we're going to be using train association, we want to basically orient ourselves to the direction of our travel or to north. So you can take your compass and you can, let's say you want to orient yourself to the environment you're in. We're going to start with north. You're going to move your bezel to north, and then you're going to rotate your compass until north red Fred is in the shed. Your orienting arrow, your needle, and your direction of travel arrow are all lined up, and that's going to give you north. So from there, you can turn your map to match the direction of travel that you're in based on these roads. Now this particular map has roads that run north and south, and so I can use those as reference lines. So if I'm on the corner of 2nd Avenue here in 5th Street, all I have to do then is find north, and then I can see that, okay, well, it's going to be one of two directions if I'm standing on 5th Street. Well, if 2nd Street is just behind me, then I know I'm facing north. Again, so we're using our terrain to associate where we're at, and then using the compass essentially to confirm that location, so that we have that kind of idea of where we are. All right. Now another way that you can do that then is you can, if the map is running, if there are grid lines on the map that are running north and south, and we don't have those other than these streets, and that's fine for the sake of this demonstration. We're going to take the base plate of this compass, the edge of this compass, and we're going to place it on a line, a grid line that's running north and south. All right, we're going to note north where that is on the map. All right, our direction of travel is going to be towards that north. And then what we're going to do is we're going to move our bezel, put red Fred in the shed. All right, so they're heading north, and then we are going to turn our entire map so that everything lines up. Okay, so a lot of times people do this to get oriented, right? To orient themselves, the terrain around them. You don't have to do north. You can do any of the directions. North is often the first thing that you would often go to kind of create a baseline. All right, and we'll talk about the different types of north in another video. And this is why you want to kind of use north as your reference. But you can do this with west, east, south, any direction that you think you might be traveling or wanting to confirm that you're traveling. Okay, so we're looking at gross directions, your cardinal directions. We're not worrying about too much about these indices. All right. So once we've kind of oriented ourselves to our environment, then what we can do is we can kind of find our position on the map and where we are. All right, so we've oriented this. Let's say we're in this park and we want to know where we're at. Well, once we've oriented ourselves, then we can see that maybe we could look left or right, and we could see, okay, yeah, we're in between this road here, this trail, and this river, and we're facing this direction. All right, and now we kind of know that since we're in the park and we can kind of see some of these boundaries with our terrain, we're going to know we're in this kind of specific area. Now if you want to pinpoint your exact location, you can use your compass to do that, and we'll talk about that specifically later. But the idea here is that we've now found our position and we've oriented ourselves. So let's say if we're at this bridge, we know that we're looking this way. We know that we're on this bridge because if we're reading our map correctly, this is the only bridge on this river near the park. that's actually in the park, right? So we're kind of using that geography to know exactly where we are going. Okay, so let's say we wanted to plot a route to travel. We wanted to create a path through this park. How would we do that? Well, we're going to use the protractor of our compass to do that. And we're going to measure the difference between, if you remember, finding a bearing is the measurement of two different points. And so when we're measuring a bearing, what we're doing is, if you remember a protractor from school, is it measures the angular distance. All right, and that's basically what we're doing, basing this leg of the angle. I remember my basic math here, but is based off of north, and this is going to be whatever degrees off of this, so we're measuring that distance, right? That angular distance. And so what we're going to do is we're measuring the distance between north and on the map and the direction that we're heading. And so we can completely ignore the needle at this point because we're not using this for orienting ourselves. North does not matter as far as this is now using this compass as a protractor, so we can completely ignore this needle. All right, we're just using the compass to measure the distance. So let's say I'm at this bridge here, and I want to walk to this bridge over here. I want to check that bridge out. All right, I'm going to want to shoot an azimuth from here to here, but let's say I can't see that bridge. Maybe I'm at home. Maybe it's obstructed by trees. But I want to get from this location to this location. So that in that time, what I'm going to do is I'm going to take the edge of my base, the ruler of my compass here, the base of my compass, and I'm going to put the two together. Right? I can even put a line between the two here. That is where I want to go. So remember, I want to judge the difference between north and this direction of travel. So what I'm going to do is I'm going to take my compass, and it has this meridian lines in here, this orienting arrow, and I'm going to move the bezel. So if north is at the top of my map, then I'm going to move these lines so that it lines up with north. Okay? Now I can use grids on the map for reference, and again, because this map has streets that are running north and south, I can use those streets as reference to know that those are going north and south. All right? And so if you look to see it, you can see these blue streets here are going to run perfectly parallel to these meridian lines. Okay? So once I've done that, I can see on the bezel here that is 30 degrees. And I can even write that on my map. So if I go to this location here and I set my compass to 30 degrees, it's going to point directly to this bridge, and I can move right to that bridge. Now, if your map doesn't have true north lines on here, then what you want to do, or have any kind of grid reference, right? There's plenty of maps like this trail map here that doesn't have any grid lines, right? Whereas this topographical map, you can see there's tons, there's different types of grid lines on here. All right. This one has none. This one has none. So what you do is, if this is north, you just add them in. You take a ruler and I'll put my own grid lines in. Right? It's not, you can create accuracy and you can use your map and compass even if there are grid lines on there. There's no reason why you can't put your own grid lines on. And so again, I'm just gonna, if I wanted to go from this park to this park, then I put my base plate onto the between the 2 points, the 2 parks right here. And then I'm just gonna move my compass bezel to north so that these lines up with those grid lines I just put in. And then when I get to that location, I'm going to move my compass. So I put red Fred in the shed, and that's going to take me to the 30 degrees. I'm sorry, 98 degrees to get to that location. So as long as I stay on that azimuth, or that baseline, then it's going to get me to that park. Now I'm going to continue to use my terrain association. I want to make sure that, for example, 5th Avenue stays on my left-hand side. That if I cross Old Hawkeye Road here, I've overshot the park. And what I can do is I can take each one of these points, these intersections on the street, and use them as increments, as waypoints along the way. So I'm going to go from, not just from here to here, but from this street to this street to this street to this street, until you get better and more comfortable, and depends on that, of course, that terrain. So using your map and compass together is super easy. It's using it as a protractor, which we just talked about, and then using it as a way to orient yourself for the terrain around you. So we've talked about plotting a course, we've talked about shooting an azimuth, we've talked about finding our position, using terrain association. Next up, we are going to talk about declination. Okay, so in the previous video, we talked about how to kind of orient yourself to your cardinal directions with your compass. We talked about how to shoot an azimuth, and then we talked about how to plot a course between 2 points, how to measure the angular distance between north and the direction of travel that we're headed. So one of the things that kind of trips people up a little bit in land navigation is what's called declination. Now, one of the things that we didn't talk about when we talked about shooting an azimuth was being careful not to have your compass exposed to any kind of metal around the compass when you're shooting your bearing or shooting your azimuth. And why that is that it creates a deviation between magnetic north, where your needle is pointing, to that source, that metal source. As you can see, this compass needle is moving away from the magnetized compass needle because it's polar opposites. Okay, so what happens on Earth is the same exact thing. When we think about declination, we want to think about declination as an interference in our direction of travel, no different from that needle being offset. So this little circle represents Earth, and north on Earth is almost always represented by an N and a star, and that is the North Pole. That's where Santa lives. Now, our compass is actually does point to the north, but it doesn't point exactly to north. It's actually pointing to a very large magnetized landmass, ferrous material, up near the North Pole. And that's where our compasses are actually pointing. So the map here on this, the north on this map here, is going north. It's going in this general direction. But our compass is actually pointing, is actually pointing to this material, this magnetic north. And magnetic north is often indicated by an arrow, just like the arrow in your compass. All right, so there's polar north and this magnetic north, and there's a predictable deviation between these two angles. And oftentimes then that's indicated as declination on a map, and it'll say 2 degrees. And so you'll see that it's being pulled west or east 2 degrees, depending on where you're at in the landmass. Some places are directly under the two places, and they both line up, and then you have 0 degree declination, and you don't have to adjust your map at all, because there's no think of it as there's no interference. Okay, you're measuring, all of your norths are lining up. Now, to make things a little bit more tricky, we don't just have there's polar north, there's magnetic north. Well, if we're looking at a map and someone has put in north grids, as we did in the previous video with the pencils, that's what's called grid north. That means there's a grid pattern going north and south. Okay? Oftentimes that's indicated by a little square. You can think of that as depicting the map itself. So that's north on the map. So we have polar north, we have magnetic north, and we have map north. Now, most of the time we don't have to worry about the difference between polar north and map north, because it's going to be one and the same. That's not always the case. Sometimes people put the map north in at the same deviation or angle difference that magnetic north is in. So then now you don't have to adjust your compass to the difference of that, for example, that 2 degree difference. Or if you're in, further on the west coast, it could be 15 degrees. And if you're further on the east coast, it could be 18. I'm just using 2 as an example. So in the previous video where we put in our lines, our grid lines, we put that in based off of map north on our lines. And that map north we're assuming is lining up to polar north. But we could just as easy put in magnetic north grid lines and put in those lines on the map. And then when we're measuring out the angular distances with our protractor, it's going to line up to the deviation of that magnetic north, where that needle is actually pointing on our map. So we don't have to correct that declination, that 2 degree difference. It makes things a lot simpler. So we have polar north, we have map north, which often runs with grid north, but not always. So polar north, map north, grid north, magnetic north, and the last north is actually celestial north, which is the North Star, way up here. And that North Star is where everything, the world, as we're looking at the stars, that's directly in the center of the sky. And the Earth is spinning below that. So it's a constant constellation in all seasons, depending on the Earth's tilt. Because if the Earth is tilted, then we're not always going to see all the stars at night in the night sky in all seasons. But everywhere you are in the United States, you can use the North Star as a reference, because it's going to be directly above polar north. And that's why when we talked about orienting our maps, we used to orient it to the east for religious purposes, originally, but also because the sun rises in the east and it gives you a predictable direction of travel in the morning. However, if we're using celestial bodies to navigate on a ship, it's going to make a lot more sense to do that based off of north and the North Star. And so now fast forward to the modern maps that we have modern maps now that have grids that can be true north or polar north, magnetic north, variants, I guess, or displayed. So you have to be very careful when we looking at a map, because that angular distance that we're measuring is going to be based off of a north, and we have to make sure that we know what north that is, so that we're getting the right measurement when we're using our protractor. Hopefully that makes a little bit more sense for you. Dealing with declination, then you can put your own grid lines in. All right, you can add and subtract that deviation. So I always remember least is east, meaning that if you are 2 degrees east, you're going to subtract. So you plot a course on your map. You take your compass into the field. You're going to go, let's say, 120 degrees. Well, since the magnetic north is going to pull that needle slightly away from that north that I've just judged the angular distance on, away by 2 degrees, I'm going to overcompensate that by subtracting 2 degrees. 198 degrees is what I'm going to turn that bearing into, so that I stay on course. Now you have a tool on your compass here that you can use for declination as well. And this helps you so that you don't have to worry about adding and subtracting. So you don't have to remember east versus adding or subtracting. Because if you take a compass bearing in the field and then you try to apply that to your map, you're going to actually have to add. So if we subtract from the map to the field, we have to go backwards. And this is where people get confused. Do I add? Do I subtract? So instead of doing that, what we're going to do is, instead of using this orienting arrow as our basis, that's 0, we're going to orient our compass based off the declination. So this black arrow here is going to be so this is where it's all lined up. If it's 2 degree offset, then we're not going to line up our red thread in the shed to 2 degrees. We're going to line that up to the offset of 2 degrees on the declination scale. So we'll put red thread in the shed, knowing there's a 2 degree declination difference. So when we're plotting our course, those meridian lines are going to be offset to the 2 degree difference based off of the needle where that's lining up, if that makes sense. So you're not going to use the orienting arrow because that's 0, which is north, 360. It's going to be lined up to the offset to that red scale. And the same, if you're in the field, you're going to set that to that 2 degree offset. So then when you bring your compass to the map to plot that route, it's going to line up always to the difference. The third thing that you can do is you can actually just purchase a compass that has a little bit of a key. It has a key in the base that turns these meridian lines to offset the compass. And you can see in the back here is backwards, and that's so that you can set your compass offset, your declination, while you're turning the key. So if you've ever wondered why these little red lines are and where it says declination, and a lot of people don't teach that for whatever reason, but I find it to be a lot easier to use this scale than it is to think about adding and subtracting, or you know, especially if you're in an area where you're not offsetting your declination. Now, if you live in an area where your declination is off all the time and you don't want to use your scales and you want to make it quicker and faster, then you can get a key or adjustable declination in your compass to do that. So it's not necessary, but it's a nice feature. The other thing I'll say about declination too is you have to be careful, especially if you're using older maps, is that declination changes over time as there's actually that landmass drifts, and so you do need to update your declination. You can go online to geomag .rnean.gn.ca. It's a Canadian website that will tell you, or there's a number, just Google declination update, and you can actually plug that into your own equation, which we can do in another video, or you just go online and it'll tell you. So the map here says that my deviation is 1 degree east. However, I'm sorry, it's a half a degree east from the location where I'm at. However, I've updated it, and this 1983 map updated in 2005 and found that the deviation, the declination is actually a full single 1 degree east, not a half a degree. So you have to be careful, because that difference over the course of travel, remember, if you're traveling from here to here and you're off 2 degrees, well, if you're only going a few feet, you know your destination's here, it's not that big of a deal. But if you're traveling over the course cross country over land, you can overshoot. That distance increases quite a bit. So you want to make sure that you're adjusting for declination if you're going over longer legs, specifically if you're going over longer legs. But if you're just shooting something in a county park, you may not see a big difference between that. And so oftentimes, again, people jump right to declination, but they're not really going over the long course of land in to need to make those adjustments to make the big difference of it. So hopefully that makes some sense. This is a hard thing to describe, but basically just remember that your needle is being pulled off at a predictable degree from true north, and you want to make sure that all of your norths align in some way, so that you are getting an accurate reading and judging that angular distance accurately based off of the right north.